Radical form. So exponential form, what's 1/3? So what power is cube root?
3/2?
No. 1/3. What power is square root? What do you do with powers of powers when you have the same base? No. 1/3 plus 1/2. So that's going to be x to the 5, 6. So you go from radical form and you translate it into exponential form.
Can't you not add numbers with different denominators?
You can if they have the same base. 1/3 plus, they don't change, equals the same thing as 2, 6 plus 3, 6, because I now have a common denominator, which equals this. Boom, 5, 6. I made a common denominator. I just skipped over the step of showing you it.
Oh, you multiplied the bottom.
Multiplied the bottom?
Because like 3 times 2.
2 over 2, yes, I got a common denominator, but I didn't actually do that right here. I just did it straight up. Different paths you can take. What do you want to do first? What do you want to do first? Sure. So that's going to be k to the 1/3 times k to the first over k to the 2/3. Now what do I do? Nope. Add the exponents on the top, so it's going to be k to the how many thirds? 4/3 over k to the 2/3. Do we have the same base? Yeah. So what do you do with the powers? So it's k to the 4/3 minus 2/3, so it's going to be k to the 2/3. Distribute. So it's going to be negative 8y to the 11/7. What do you do with the 3/7? Add it. And then it's going to be plus 8y to the 11/7 plus negative 4 over 7. What's 11 over 7 plus 3 over 7?
14 over 7.
14 over 7 plus 8y to the 7 over 7. 11 minus 4 is 7. What's 14 over 7? So that's going to be negative 8y squared plus 8y. All done. Distribute. You could just keep the negative 8 on the outside the whole time if you wanted to, but it's fine. Thing that we're going to add in now is that if you have the same radical, you can multiply the bases. So for example, if you had the cube root of 7 times the cube root of 8, that would be the cube root of 7 times 8. That's one thing you are now allowed to do. Sometimes that will be helpful. Here's what the quotient rule looks like. Well, if you have the nth root of a over b, you can do each one separately. So for example, the cube root of 64 over 27. That's going to be the cube root of?
So that's what we did.
The cube root of, we just did, yep. So that's going to be, what's the cube root of 64? 4. Cube root of 27?
3.
Done. So this is what I'd like you to do right now with this new information. Simplify the top 3, A, B, and C. Simplify those 3 right now. So to reiterate, when you have a cube root, what do you look for? Triple. When you look for square root, you look for pairs.
So does it go off like?
Yeah, you could. Absolutely. Okay, try these for me. Simplify those 2. Smallest number you can pull out. 2 and?
100.
Hey, you could stop there because what do you notice 100 is? Is a square, right? So if you want to break this apart, this would be the square root of 100 times the square root of 2 times the square root of k to the 7th q to the 8th. What's the square root of 100?
10.
So that's 10 root. So we're not done yet. Times this. We're not done. Q to the 8th. What power is square root?
2.
One half.
No, it is not 2.
Oh.
It's a half. If I say what power is square root, you have to say half, not 2. So you could write this as 10 root 2 k to the 7th q to the 8th to the what power? What do you do with the power when you have powers of powers? Yeah, you multiply, distribute, exactly. So this is going to be 10 root 2 times k to the what power?
3.5.
7 over 2, and then q to the 4th. This is mixed. You see how there's both radicals and exponents in there?
Yeah.
That's fine too. I like that because root 2 as a radical, I'm finding like all the coefficient is one thing and all the radicals are another. But the point is, it's debatable, like what's more simple. Is this simpler than this? I kind of like this a little bit better than this, but I'm showing you what you can do. So what is half of 8? 4. What's half of 7? 7 over 2. Stop there. Stop there. Yes?
So you don't try to, I messed up, I try to figure out.
Root.
1/3.
1/3. So it's going to be negative 2 times x to the 4th, y to the 5th to the, what do you do with the power? So it's going to be x to the 3rd, y to the, I like that. It's debatable whether this is more simple than this, but I like the bottom one. That's my preference. So moving on, let's go to something you've seen before. Remember this? In a right triangle, the sum of the squares of the legs of the hypotenuse, legs of a right triangle equal to the square of the hypotenuse. This is also known as it's known as the most proven theorem in the world. More cultures independently prove this, independently of one another, than any other proof. There's lots of ways to prove this. We're not going to prove it, but there's lots of ways to prove them. There's a lot of, this theorem allows us to do many things. This theorem allows us to do many things. One of them is, for example, find this length. If I wanted to find C, can someone, without writing anything down, just state out loud in any form they want, what is that going to be equal to? Yes?
6 squared plus 4 squared equals C squared.
That's true. Can you tell me what C equals? I want you to do more math in your head. What does C equal? C is going to be equal what?
36 plus 16.
No, keep going.
Yeah, no, it's equal to that.
No, keep going. Keep going. So you
52.
The square root of 36.
C squared is equal to 4 squared plus 6 squared. So C squared is equal to 16 plus 36. So C squared is equal to 52. So what does C equal? That's what I wanted you to say right there. So if you have a right triangle, can you always find the hypotenuse? Actually, if you have any two, can you find the third side?
Yeah.
Absolutely. So are you okay with that? It has to be what triangle?
Right.
Has to be a right triangle. Has to be a right triangle. So what can you do? Well, let's put that right triangle onto a graph right here. Let's put it onto a graph. So let's call these points A, B, and C. What's the distance? Can someone tell me what the distance is from A to B? From A to B. What is the distance from A to B? The length of side AB. What is it?
7.
It's 7, exactly. What's the length of BC? Someone else. Can someone tell me what is it?
8.
It's 8. How did you get 8?
Because when it's horizontal, you look at the x's.
Yeah, so it's going to be 3 minus negative 5 is equal to 8. How did we get 7 right there?
4 negative
3 minus negative 4 is equal to 7. So we have two of the side lengths. What does that mean we can now find? The hypotenuse. So the length of the third side, so the length of AC, the magnitude of AC, what's that going to be equal to? The square root of 7 squared plus? So that's the square root of 49 plus? That's the square root of 113. What did we just find? We just found the length, which is also the what between these 2 points? The distance between what? Between A and C. Now this method can be used to find the distance between any 2 points. Because if you have 2 points, what can you always draw? You can always draw a triangle. Exactly. So how about this? Give me a point, any point you want.
6, 4.
6, 4. Give me a completely different point, Sarah Marion.
9, 7.
Let's make it 9, negative 7. Go to the board, everybody, with a pair and find me the distance between those 2 points. Sure. And it's going to be, you're going to end up doing something like this. The square root of 9 minus 6 squared plus negative 7 minus 4 squared. Doesn't matter what direction you go in as long as it's the same direction. So that's going to be the square root of 3 squared plus 3 squared plus what?
11 squared.
11 squared. So it's going to be the square root of 9 plus 121, which is the square root of 130. Yes.
Can I get the board over there, please?
There you go. Good job. So you'll notice I did 9 minus, see how I said 9 minus 6 and negative 7 minus 4? This is really important, everybody. Does it matter what order you subtract in? Because you're squaring, you can get away with subtracting in any order you want because any number squared is going to be what? Positive. I highly recommend going in the same direction. Just go in the same direction. It's highly recommended. Okay.
Ready, read me the coordinates.
There you go, kids. What does negative 2/3 power mean?
Cube root of
1 over negative 8 to the what power? 2/3. What does 2/3 power mean?
the cube root of
The cube root of negative 8 squared. So it's 1 over negative 2 squared, which is 1 over 4. Is the same thing as negative 2 cubed. What do you do with powers of powers?
Multiply.
So that's going to be negative 2 to the 3 times negative 2/3. What happens to the 3's up there? Negative 2 to the negative 2. So that's 1 over negative 2 squared, which is the same thing. Should be the
Got a
same
lot
thing.
of correcting to do on this.
Okay, kids, you can get at it first.